So let's start with the Pythagorean theorem and some pretty interesting properties of right triangles and altitudes and how it creates other similar triangles. All right, so this theorem 541 is just a mouthful, but we're gonna draw a diagram and I think it'll be a lot clearer to you. So an altitude drawn to the hypotenuse of a right triangle separates the right triangle into two other right triangles that are similar to each other and to the original triangle. So the best way we can describe that is let's just draw a nice right triangle. There's my right angle. We'll call that angle C, and here's angle A, and here's angle B. Obviously, we have triangle ABC. So let's draw hypotenuse, let's draw an altitude to the hypotenuse. Altitude is from a vertex, perpendicular, in this case to the hypotenuse. That has just created two other triangles. So we have the big purple original triangle. Now we have the smallest triangle here, which is also a right angle. And then we have, we'll call this the middle size one, right? It's the original is the biggest and the blue one is the smallest. All three of these triangles are similar, same shape. They're not the same size. So triangle ABC is similar to triangle, all right, so let's look at this smallest one first. In the original triangle, the right angle is named last. So we're going to name Z last. In the original triangle, the vertex that's opposite the shortest side is named second. So that's going to be, in this case, A. C, A, Z. C, A, Z. And then for this triangle, what's the third one? That's similar to triangle C, B, Z. So that has created, there's actually a picture on the next page, a triangle with an altitude to the hypotenuse will create two other triangles that are similar to the original triangle. All right, and then let's talk about if we have a right triangle. Whoa, here's a right triangle, and let's draw a hypotenuse, altitude to the hypotenuse. Altitudes are by definition perpendicular. So we know in the original triangle this is the hypotenuse. So we'll call this the left leg because it's to the left of RC, and we'll call this our right leg. Pardon me. And we'll call this breaks the hypotenuse up into segment 1 and to segment 2 because we're going to talk, we're going to be talking about some different theorems, and they can get kind of wordy. So we want to make sure we understand what's the altitude, what's a leg, and what's a segment. What's the altitude, what's a leg, and what's the adjacent segment, or what's the adjacent leg. That's the vocabulary we're going to be using for these next theorems. All right, so the length of the altitude to the hypotenuse of a right triangle is the geometric mean All right, there's a right triangle. There's an altitude. Here's my left leg. Here's my segment 1. Here's my segment 2, and here's my right leg of my original triangle. The altitude is the geometric mean. Geometric mean means it goes here. The altitude is the geometric mean, the same number and the insides, not the extremes. The altitude is the geometric mean of what? The lengths of the segments of the hypotenuse. So it's the geometric mean of segment 1 to segment 2. That's theorem 542. The altitude is the mean between those two lengths. Let's look at 543. The length of each leg, so here's the left leg, here's the right leg. The length of each leg is the geometric mean. Okay, so let's look at this one here. We'll say the left leg is the geometric mean. That means it's in that position. The length of each leg is the geometric mean of the hypotenuse, the entire hypotenuse, and the length of the segment. So the left leg is the geometric mean of the hypotenuse in segment 1. Here the right leg would be the geometric mean of the hypotenuse in segment 2. That's what that's saying. And then the standard Pythagorean theorem, the square of the length of the hypotenuse of a right triangle is equal to the sum of the squares of the lengths of the legs. We've seen that. We've seen that a lot. We've used that a lot. All right, let's keep going. So if I'm given this triangle, and I'm showing here that it's a right triangle, let's do condition A. We know using Pythagorean theorem that RT squared is going to be SR squared plus ST squared. That's the Pythagorean theorem. They want us to find RT if RS is 3 and ST is 4. So RT squared is going to be 9 plus 16. Or RT squared is going to be 25. Take the square root of both sides, and we have the length of RT is 5. Now let's do condition B. Just writing Pythagorean theorem. RT squared is going to be RS squared plus ST squared. They want us to find ST if RS is 6 and we were told RT was 9. So I plugged 9 in for RT and 6 in for RS. And so we're going to get 81 is going to equal 36 plus ST squared. Let's subtract 36 from both sides, and we get 45 is equal to ST squared. So if I want to get ST, I'm going to take my square root of both sides, and you're going to use your calculator, and you don't come up with an exact answer, so that's why we're going to write our approximate symbol. Approximately 6.71. ST is about 6.71.